Hi guys, Mr. Hill here with your maths for today. So we've been looking at comparing and ordering fractions less than 1. We're going to go over 1 now. We're going to go into fractions that are greater than 1. So we're going to have some improper fractions, and we're going to be carrying on working on how we can make fractions to have the same denominator or the same numerator so that we can compare them and then put them in order. Before we get started on that, have a go at these questions. Can you make these statements correct? What do you need to remember for them? Pause here to have a go at this. Okay, how did we get along? So 11/6 is equal to, so we need to look at the relationship here between 6 and 36. 6 times 6 is 36, and I need to remember what I do to my denominator in this case. I also need to do to my numerator. So it should be 66. For part 2, question 2, we need to look at the denominators again. And I've got 29 over 20, 25 over 10. So I need to make it so that I've got something over 20. I could have done it the other way around. I could have divided 29, but the problem is I'd have ended up with a decimal number, and I can't have decimals with my fractions, so it's easier to multiply. So I've multiplied it all by 2. And now I need to remember, when the new denominators are the same, the greater the numerator, the greater the value of the fraction. And I can see there 50 over 20 is greater than 29 over 20. So 29/20 is less than 25/10. Question 3. There's a multitude of answers here. You can have lots of different answers. So we need our fraction to be greater than 2. We could have 24, you could have 25, you could have 35, you could have 135. So long as it's more than 22, it will be correct. Now, question 4. We can't easily multiply the denominators to make them equal. I can, however, multiply my numerators. I know that 8 times 2 is 16. So 16/12, is it greater than, less than, or equal to 16/14? And what I need to remember here is where the numerators are equal, the larger the denominator, the smaller the fraction. 12 is smaller than 14, therefore 14 is a smaller fraction. So 16/14 is less than 8/6. So we're going to have a look at these fractions, and we're going to put them into ascending order. So we're going to start with the smallest, and we're going to work our way to the right hand side of the screen to finish with the largest. So we've got 2/3, 4/9, 5/2, and 20/17. So we need to work out what's going to be our most efficient way of comparing these. So we're going to look at the numerators because they're all factors of 20. So we can make them all equal to 20, and then we're just comparing the denominators using our rule at the bottom of the page, where the numerators are the same. The greater the denominator, the smaller the fraction. So 2 times 10 makes 20. I also need to remember what I'm doing to the numerator, I need to do to the denominator. So 2/3 becomes 20 over 30. 4/9, 4 times 5 is 20. So I'm multiplying both numerator and denominator by 5 to give me 20/45. 5 times 4 will give me 20. So 5/2 becomes 28. And our final number, I don't need to do anything with. It's already got 20 as the numerator. And now it's just a question of looking at the denominators. So I want to start with the largest denominator because that's the smallest fraction. So 4/9 is the smallest fraction there. So 20 over 45. So remembering our rule that's written at the bottom of the page, that's the smallest we have. Going to cross it out as well so I don't accidentally write it in again and end up getting this answer wrong. The next one is 2/3. Cross it through again. Then 20/17. 17 is greater than 8, but when we use the rule that's at the bottom of the screen, it's got less value. It's a smaller fraction. And then we finally have our 5/2 on top. And we'll cross that through as well. Okay, over to you for this one. Have a think here. What can you do to these fractions? Now, they might not all be multiplying to make them the same. You might be able to divide them as well, bring the numbers down a bit and make life a little easier for yourself. So this time you're going to order the fractions in descending order. So you need to find the biggest first and work your way down to the smallest. And remember the rule at the bottom. When the numerators are the same, the greater the denominator, the smaller the fraction. Pause the video here to complete this. Right, how did we get on? So we've got 60 over 32. That's the first one we're going to look at. Now, 30 is a factor of 60. So 30 times 2 makes 60. So I could divide that one by 2. So I need to look at my numerator, and I can because 32 is an even number, so it is divisible by 2. So 60 divided by 2 is 30. 32 is 16. So 30 over 16. We then have 1/2. We're going to multiply 1 by 30 to give us the 30 as the numerator. What I do to the numerator, I do to the denominator, 30 over 60. And our 5/4 at the end is going to be multiplied by 6 because we know that 6 5s makes 30, 30 over 24. Now, I need to look at my denominators and I need to work in descending order. So I need to find the largest one. So if I look along, the smallest denominator I've got is 16. So I need to remember the greater the denominator, that's smaller that fraction. So the 16 is my biggest fraction. So 60 over 32 is my first one. So I'm going to cross that out. So remember, don't accidentally use it again. The next one is 30/19, then 5/4, and then 1/2. Well done if you got that. So we've got some new fractions here. We're going to put these in ascending order. So where the denominators are the same, the greater the numerator, the greater the fraction is the rule we're going to remember here. We can also look at the relationship between the denominator and the numerator. So we've got our 3 here are all factors of 12. So I can do 4/3 times 4. So that will give me 16/12. 10/6, multiply that by 2 to give me 20/12. Now I can now compare 3 of my numbers, but I've got 1 left over, 11/5. 10 is double 5. We've got 11 here, so 10/5 makes 2. So our number 11/5 is greater than 2. So I can look at the other numbers, the other fractions we've got. They aren't any greater than 2, so I can now order these ones. And I know that 11/5 will be my biggest. So I'm going to put that in first and cross it through. And now I'm just comparing my fractions as we know we can. So all the denominators are the same. So the greater the numerator, the greater the fraction. So 4/3, 19/12, and 10/6 there will be our sequence. So have a look at these ones. 3 of them you can work with. 1 of them you will need to do something different with. So the same as we did on the previous slide. Have a go yourself and see how you get on. How did we get on with that? So what we need to do, going to make things to 40. So 5 times 8 is 40. 7/8 makes 56. And double this one here. So 25 times 2 is 50. And we've got our new denominator on the bottom there of 40. Now we've got 10/11ths left over. So we need to have a look at how we're going to deal with this. So a proper fraction is another way of solving this. 10/11ths is less than 1. All of our others are improper fractions. They are greater than 1. So 10/11ths is the smallest fraction I've got. All the others, I've done the multiplications. I've got all the denominators to the same value, and I can put them in order. So this one here, 5/7 is less than 15 somethings is less than 15/9. So 5 times 3 makes 15. So I've got 15 over 21. So that means we know the greater the numerator, the greater the denominator, the smaller the fraction for this one. So when the numerators are the same, the greater the denominator, the smaller the fraction. So any integer, so any whole number between 10 and 20 will work. So I've gone for 11 for this one. So have a look at this one. What could go in the box? I'll give you a clue. Think of your 7 times table. That will help you to work for the equivalent fractions here. Pause now. How did we get on with this one? So 4 times 7 will make 28. And I need to remember what I do to the denominator, I must do to the numerator as well. So it becomes 12 over 28. Now, 14, I can multiply by 2 to get to 28. So I need something to go in the box on top. So any integer between 3 and 11, would that work? Let's try 7. Now I need to go back to being over 14. So I need to divide this by, if I divide it by 2, 7's not an even number, is it? So I will have a decimal there. And I can't have a decimal number in a fraction. So I need to revise my statement. It needs to be an even integer between 3 and 11. So I can divide it by 2. So it could be 4, 6, 8, or 10. In this case, I've gone for 6. So if I go back up and convert it into something over 14, so I divide it by 2, I have 3 over 14. So it's just something to be careful of where you're converting your fractions to have similar denominators. For number sequences, you need to think about what happens when you do the inverse to put it back to where it should be. So here we've got 1/2 is less than something over 21 is less than something over 18. So half of 21 is 10.5. Now we know we can't have a decimal number in a fraction. So any integer between 11 and 17 will answer this question. So I've gone for 12 here. So a bit of reasoning for us. Rosie and Jack each have 3 identical bars. Jack divides each of his bars into 4 equal pieces and eats 5 of them. Rosie divides each of her bar into 2 equal pieces and eats 5 pieces. We've both eaten the same amount because we've both eaten 5 pieces. Can you explain to me why Jack is not correct? Pause the video here, read the question carefully, see if you can work out why. Did you get it? Let's have a look. So we've got 3 chew bars each. One of them cuts them into 4 pieces. So he's got 12 quarters in total. The other one cuts them into halves. 6 halves in total. So, having eaten 5 of those quarters, he's got 1 full bar and 3/4 of a bar left, or 7 quarters remaining. Here we go. We've only got 1 half remaining. So 7 quarters is greater than 1 half. We can check this by making the denominators the same, so multiplying it by 2 and remembering where the denominators are the same, the greater the numerator, the greater the fraction. So 7 quarters is greater than 1 half. Now it's your turn. Have a go at these questions. If you're struggling, go back, rewatch the part of the video that talks you through the process to do these. Maybe write one of the sequences down, or all 3 of the sequences down if that's what you need to do. Help yourself and work it through. Pause here to complete your work. Okay, moving on. Here are your answers. Pause the video here to check your answers. Your turn again. We've got some different questions to have a go at. So Alex and Dora have 2 identical cakes. Alex cuts each of her cakes into 6 equal pieces and gives 10 of her friends a piece each. Dora cuts each of her cakes into 12 equal pieces and gives 18 of her friends a piece each. Who has more cake left? And a bit of thinking, the greater the numerator, the greater the fraction. Can you give at least 3 examples to show me why that statement is not correct? Pause the video here to have a go at these. How did we get on? Here are your answers. So Alex and Dora have the 2 identical cakes. Dora has more cake left. So let's just have a quick look why. So I've got sixths. So I've got sixths is my numerator for Alex's cake, and she's given away 10 sixths. Dora has given away 18 twelfths. Now, there's 2 ways round we can solve this. We can multiply this one by 2 to get our denominators to be equal, or we can divide this one, so 18 twelfths by 2, to make these equal. So depending on which way round we did it, so if we do it by dividing, I'm going to divide by 2, so it becomes 9 sixths. So who has more cake left? It's going to be Dora, because she's given away less of her cake. So looking at our other question, the greater the numerator, the greater the fraction. Give at least 3 examples as to how we know this statement is not correct. So there's lots of ways of showing this. We'll have a look at the one that's on screen. We've got 3/17 is less than 1/2. Well, this one we know because 3 is not anywhere near half of 17. Half of 17 is 8.5. So this is not correct. So it shows that we have a larger numerator and it's still not the same over the denominator. We could make this 10 times bigger, and we could have 30 over 170. It's still the same. It's still not more than halfway over. So we still have a much smaller numerator, but the fraction is still greater. Share your answers for this one on Tapestry. We'll have a look, and we'll maybe compare some of our answers in our live session on Wednesday. Well done, guys. You worked brilliantly today. Take care, stay safe, and we'll see you soon.